Today we're going to talk about finding all the missing sides and angles of a right triangle using trig. So recall here, to solve for x, which is an angle, we circle the reference angle, label our sides, hypotenuse, opposite, and adjacent. We circle the sides that we know. So we know hypotenuse and opposite, which means we're going to be using sine. So sine is opposite over hypotenuse. Sine x is 10 over 12. And remember, to undo that sign, we use inverse sine. So inverse sine of sine x equals inverse sine of 10/12. And if I put in inverse sine of 10/12 into my calculator, make sure that your calculator is in degrees and not radians. And we would end up that our angle is approximately 56.44 degrees. So recall that's how we solve for an angle. Here, solving for a side, when we already know two of the sides, we'll be using the Pythagorean theorem. A squared plus b squared is c squared. Remember, we always label c first, which is our hypotenuse. A and b don't matter. I'm going to call A 3 and B 4. So then it's 3 squared plus 4 squared is c squared. 3 squared plus 4 squared is 25. And then to undo the squared, we have to square root both sides. And we get that c is 5. This one, solving for an angle when we already know two of the angles. We know the whole triangle needs to add to 180. So if I just do 180, take away 90, take away 56, I would get that that last angle is 34 degrees. So using those, we are going to find all of the sides and all of the missing angles. I'm going to label this here quick just to make it a little bit easier on ourselves. So we need to find side AB, we need to find side BC, and we need to find the measure of angle C. Well, the measure of angle C will be the easiest one to start with because I just have to do 180, take away 90, take away 42. And I would get that that last angle there is 48. So the measure of angle C is 48 degrees. I'm going to write that in there. So now we need to find AB and BC. So solving for a side, we pick our reference angle. I'm going to use my reference angle of 42. So we have the hypotenuse, the opposite, and the adjacent. And here I'm solving for AB, so I'll call that my X. We need to find our adjacent, and we know our opposite, so we're going to be using tangent. So tangent of 42 equals our opposite over our adjacent. And then recall solving this, we solve it like it's a proportion. So x times tangent of 42 equals 8. Dividing both sides by tangent of 42. We would get that side AB is approximately 8.89. And then to find our last side, we can use the Pythagorean theorem. So now I'm going to relabel my sides as A, B, and C. I know the hypotenuse has to be C. I'm going to call that A and that B. So A squared plus B squared is C squared, which which means 8.89 squared plus 8 squared is c squared. And if we do 8.89 squared plus 8 squared, we get 143.0321 equals c squared. And then if I square root both sides here, I would get that c is approximately 11.96. So our last side then is 11.96. So those are our 3 answers. You're going to have 3 answers for all of these. Let's look at this one. So we need to solve for the pink angle, the blue angle, and that side. Let's start by solving for the side because we can just use a Pythagorean theorem. Again, I'm going to label this. So we need to find the measure of angle A, we need to find the measure of angle C, and we need to find the length of side AC. We'll start with side AC. If I'm using the Pythagorean theorem, I know that has to be my hypotenuse, so that's A, and then we have B and C. So 6 squared plus 10 squared is c squared. 6 squared and 10 squared is 136. And then square rooting both sides, we would get about 11.66 for that side. So side AC is about 11.66. So now we need to find either the measure of angle A or the measure of angle C. I'm going to do the measure of angle A. So if A is my reference angle, this is my hypotenuse, my opposite, and my adjacent. I know opposite and adjacent, so I'm going to be using tangent. So tangent of A is opposite over adjacent, or 6/10. Solving this then by doing inverse tangent on both sides. The inverse tangent and tangent cancel out. So then I have that the measure of angle A is approximately 30.96 degrees. We'll change that to approximately, which means the measure of angle C then, I just have to do 180, take away 90, take away 30.96, and I would get that the measure of angle C is about 59.04 degrees. So again, we found 3 different values here. Let's try another one. We need to find ST and the measure of angle T and the measure of angle R. We'll start with ST first. That'll be the easiest one because we can use the Pythagorean theorem to find it. This has to be my C. I'll call this my A and this my B. So A squared plus 5 squared is 5.7 squared. A squared plus 25 is 32.49. Taking 25 from both sides, I get that A squared is 7.49. And then square rooting both sides, I would get that A is approximately 2.74. So that's ST Now I'm going to find the measure of angle T. So if T is my reference angle, we have the hypotenuse, the opposite, and the adjacent. Because my adjacent side, 2.74, is an approximation, I'm going to be using the ones that I actually know are exact, the opposite and the hypotenuse, so sine. So sine of angle T is 5 over 5.7. And then solving this, inverse sine on both sides. And these two cross or cancel each other out. So I would get the measure of angle T is approximately 61.31 degrees. And then to find the measure of angle R, I can just do 180, take away 90, take away 61.31, and I would get that the measure of angle R is approximately 28.69 degrees. Again, we have 3 different answers here. Couple more examples. We need to find AC. We need to find the measure of angle A and the measure of angle C. Let's find AC first. Using the Pythagorean theorem, 5 squared plus 7.5 squared is C squared. This gives me 81.25 is C squared, and then square rooting both sides, we would get approximately 9.01. So now we're going to solve for the measure of angle A. So if A is my reference angle, we have our hypotenuse, our opposite, and our adjacent. Again, I'm going to be using the 2 values that I know to be exact, so opposite and adjacent. So tangent of A is 5 over 7.5. Doing inverse tangent on both sides. Again, the inverse tangent and the tangent cancel. So then we get that the measure of angle A is approximately 33.69 degrees. And then finally, for the measure of angle C, we can just do 180, take away 90, take away 33.69, and I would get the measure of angle C is approximately 56.31 degrees. All right, one more example. We need to find AC, the measure of angle A, and the measure of angle C. We'll start with AC. That's just using the Pythagorean theorem. So label our A, B, and C. We have 10 squared plus 12 squared is C squared. So 244 is C squared. And square rooting both sides, we get about 15.62 is C. So AC is about 15.62. Now we're going to find the measure of angle A. That's our reference angle. We have our hypotenuse, our opposite, and our adjacent. It looks like we're dealing with opposite and adjacent again, so tangent. So tangent of A is 10/12. do inverse tangent on both sides. The tangent and inverse tangent cancel, so the measure of angle A is approximately 39.81 degrees. And then again, to find our last angle, we'll just do 180, take away 90, take away 39.81, and we would get approximately 50.91 degrees. All right, so remember, you're always going to be solving for 3 different things. Make sure you're finding 3 different answers for each of these problems. Bye, friends.